Now here is a magnetic coupled circuit. Their individual reactants are given and mutual reactance is also given. Okay. Now he's asking what is V naught. So if you want to find V naught, definitely you must require what? I2. Okay. V naught and I1, I2 also can be determined. But I1, I2 unless you find, I2 unless you find I2, you cannot find V naught. Agree all of you? Okay. So let's find I2. Then we find V naught by multiplying it by 10. Clear all of you? Okay. So let us apply mesh analysis. Mesh analysis, when you apply the first equation, loop 1, minus 4I1 minus J8I1. This is self, but what is the mutual? J1 into I2. But this is entering. This is also entering. Therefore, same sign, minus. And plus 120 at an angle of 45 degrees is equal to 0. This is the first equation. Loop 2, when you take minus 10 I2 minus J5 I2, this is self. Self always I am taking fallen voltage negative, that's it. But what is the mutual here? J1 into current flowing through the other coil, I1. Entering, I1 is entering, I2 is also entering, therefore minus. That's it. So just apply Cramer's rule into I1, I2 is equal to the voltage component you get here and solve all this. You will get I1 is equal to something and I2 is equal to something. Once you know I1 and I2, what is V naught? V naught value is 10 into I2. That's it. You will get the value. So you please solve the equations. I'll give the answer here directly. The answer for this is 1.2 at an angle of 45 degrees. You try for I1. This is going to be 12 at an angle of 45 degrees. Okay, if you simplify these two equations and get I1 and I2, but we want just only I2, so eliminate I1. Cramer's rule, when you apply, directly find I2 value. I2 is nothing but delta 2 by delta. I think all of you know it, Cramer's rule, delta 2 by delta. So what is these values and all? You can, arrange the equations into matrix form. Okay, now let's go for another question here. You please note down the answer. You can solve on your own. You must be very good at calculation part. I'm telling you, calculator operation in the complex mode is very, very important. So if you do not understand how to operate the calculator, you can't do all these problems I'm telling you. Second problem, what is asking I1 and I2? Straight away is asking I1 and I2. So even the first question, even if it doesn't ask I1, I2 and asking directly V naught, we have to find the loop currents only. Understand? Okay. So here is asking I1 and I2. Let's apply the directly the mesh analysis in loop 1 and loop 2. Loop 1 and loop 2. Look at this, all of you. These two are conductively as well as inductively, both are coupled because there is a connection between the two coils. Now tell me, minus of 5 I1 minus J2 I1, but mutually induced EMF. The EMF induced in the primary coil due to the current flowing through the secondary coil. What is the current flowing through this coil? Tell me. The coil current here it is either I1 minus I2 or I2 minus I1. Yes or no? Let me assume that I1 greater than I1 minus I2 is flowing here. When I'm writing the equation in the first loop, let me assume I1 greater than I2. It's a common practice. We did many problems on this, right? So minus J2 I1. I1 minus I2 is flowing in this way, let us say. Let us assume. Then J3 is the mutual reactance. Yes or no? J3 is mutual reactance into current flowing through this particular coil is what? I1 minus I2. You can take either I1 minus I2 or I2 minus, it doesn't matter. But observe the direction of that particular quantity. I1 is actually entering. I1 minus I2 is leaving. When one is entering, the other is leaving. Opposite sign of the self-induced EMF, that means plus. Now this part is over. Now next one is what? Minus 6, J6. What is the current flowing to this? I1 minus I2. This is self. But what is the mutual again? Again J3. Current flowing through this coil is what? I1. But what is this I1 minus I2 doing? Leaving at the dot. What is the I1 is doing? Entering at the dot. Okay. Opposite sign. So plus. Not over. 1, 2, 3, 4, 5, 6. Total 6 terms will come. Because 1, self and mutual. 3, 2, 3. Self and mutual. 4, 5. And another term here. Totally 6 terms. So 1, 2, 3, 4, 5, 6. Now the plus 100 at an angle of 60 is equal to 0. Equation. Loop 2. Okay. What is the loop 2? Minus of minus J4 into I2. Minus J6 into, let me assume I2 greater than I1. I2 minus I1. This is self. This is self. But what is mutual? In this loop, there is only one coil. Its self and mutual should come. 1, 2, 3. 2 is self. 3 is what? Mutual. So total 3 terms will come. So minus J6 into I2 minus I1. Again, J3, that is mutual reactance, into I1. But what is this I2 minus I1 doing? I2 minus I1 is doing entering. I1 is entering. Self minus, therefore mutual is also minus. That's it. So again, you have to form into matrix. Here 2 by 1 matrix. Here 2 by 2 matrix. Here 2 by 1 matrix. 2 by 1 matrix. 2 by 1 matrix. 2 by 2 matrix. If you solve for I1 is equal to delta 1 by delta and I2 is equal to delta 2 by delta, please simplify it. You can do it. Okay. That's not a big deal. You can do it. This is 2 by 2 matrix, 2 by 1 matrix, 2 by 1 matrix. That's it. I'll give you answers directly here because it takes time if I simplify on the board. But again, it's your job to simplify. You must be good at simplifying equations, right? So 17.889 at an angle of 86.57 ampere. 26.83 at an angle of 86.57 ampere. That's it. Understand all of you, okay? Please note down. Meanwhile, I just remove this part, okay? Now you can try for the third question. What is asking Zn? Input impedance across these two terminals. Okay. This is the source, input source to this entire circuit, and is asking you to find the input impedance. So let me just give you the question clearly. Here J8. J10 ohm, J3 ohm. These are the dots. Clear? Understood all of you? Zn is asking. The data is J8 ohm, J10 ohm, J3 ohm mutual reactance. Dots are located like this. The dots are already given. Is asking input impedance. Is asking input impedance. So this is not an ideal transformer to convert secondary into primary. You cannot do that. It is not possible. Understand all of you? And you do not know what is the turn ratio also. Getting? So therefore, you cannot do that. But now, you can solve in a different way that using old amp technique. In magnetic coupled circuits, when all values are given in impedances and no ideal transformer is present, okay, better you always apply old amp method. So according to old amp method, connect a source where the voltage, where the impedance is required. So already source is available. Assume it is delivering some current I. Okay, assume it is delivering some current I and find the ratio of this voltage to current, you will get impedance. Simple. So now let us assume this is I. That means the current flowing here, it is I. Otherwise I1, let us say this is I1. The current flowing in this one is what? I2, let us say. Understand? Now let us apply mesh analysis. Eliminate I2. Get the relation between 40 volts and I1, or else directly find I1, nothing but ratio of 40 volts to I1, nothing but impedance. Right? So let's apply KVL in that. Loop 1. What is that loop 1, Anna? Minus 4 I1 minus J8 I1. But that is self only. Mutual is what? Mutual is what? J3 into I2. But I1 is entering and I2 is also entering, therefore minus plus 40 at an angle of 0 is equal to 0. Equation 1. Loop 2. Loop 2, minus of minus J6 into I2, minus 6 I2, minus J4 I2. You see here also there is an inductor, but there is no mutual relation between this and this and this and this. There are 3 inductors, but only between 2 inductors there is a mutual relationship. Okay, mutual induction. So therefore, minus J4 I2, only self-induced EMF, no mutual induced EMF for that. Coming to this, minus J10 I2, this is self-induced EMF, but there is also mutual induced EMF. J3 into I1, that is I1 is entering, I2 is also entering, therefore self-induced EMF minus, mutual also minus, is equal to 0. That's it. Solve for 1 and 2, solve equation 1 and 2 and get the value of I1. Once you know I1, you will find Zin, that is 40 at an angle of 0 divided by I1. That's it. Understand all of you, okay? Shall I give the values here? Just note down here. I just give the values. I1 is nothing but 4.662 at an angle of minus 58.05 amperes. If you divide that 8.58 at an angle of 58.05, okay, ohms. That's it. This is how you generally do the problems. Getting all of you, okay? Please note down that. Now let's move on to series combination of 2 inductors. They're connected in series and asked to find what is the equivalent inductance. Okay, asked to find what is the equivalent inductance. I think you finished this, right? Okay, let's go for this now. Okay, so we need to actually indicate the inductors like this, but dots are very important. For dots, you know how to find. First, you identify one coil. Okay, identify here. Identify the terminal where the current enters. Yes, I identified here with an assumption some current entering. The current is flowing like this. According to Ampere's law, some flux produces. Okay, flux links with this particular coil. Faraday's law of electromagnetic induction principle says that EMF is also induced in it. The flux direction can be determined by holding the coil, stretching the fingers along with the current direction. Thumb indicates the flux direction. So the flux emanated by the first coil is in this direction. But the flux emanated by the secondary coil will try to oppose the flux emanated by the primary coil according to Lenz's law. Therefore, now you can take this and hold the coil because you know the flux direction. Knowing the flux, you can find the current. Current in the backside part of this particular non-magnetic core, the current is in upward, but front side of the winding you will see downward. That means this way. So where is it entering? Entering here, leaving directly here. So here is a point dot, here is a dot. So these are the terminals. Remember, the equivalent inductance in case of magnetical coupled circuits can be determined always using Oldham method. Use Oldham method. Okay. Again, connect one source across the terminals, V of t, deliver some current I of t. This is L1, this is L2, and this is M. Apply KVL in this equation. V of t minus L1 d I1 of t by dt. Yes or no? But this is self. This is self. There is mutually induced EMF in the primary because of the current flowing through this. What is the current flowing through this? The same current is flowing. Okay. Therefore, M d I2 of t, but I2 is I1, both are I only. Dt. The I1 is entering, I2 is also entering. Same sign, you will get minus. This is the story of only L1, but now L2. Minus L2 d I2, nothing but I dt, and minus M d I1, nothing but I dt is equal to 0. So from this, you have self-mutual, 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 and voltage source. Total 5 terms. So V is equal to L1 plus L2 plus 2M of di by dt. This is the total voltage, total current. V is equal to LdI by dt. This is nothing but LAB. Okay, so LAB is equal to L1 plus L2 plus 2M. These two coils are connected in series in flux aiding case. Yes or no? Because this is minus, this is minus. Means having same polarity. So net EMF increased. That means net flux increased. That means both the fluxes are flowing in the same direction. Agree all of you? Flux emanated by the primary. Flux emanated by the secondary, which is linking with the primary. Both are flowing in the same direction. Therefore net flux increased. Therefore this is flux aiding case. So sometimes we will tell two coils are connected in flux aiding case. So what could be the equivalent inductance? L1 plus L2 plus 2M. Understand? Okay. Please note down that. Fifth problem. Now the coils are connected like this. Let us see what will happen. To find this LAB, definitely I told you already the Oldham method is required. For that we need dots. So let's find the dots. So identify the terminal where the current enters in the first coil case. I'm assuming some current is entering here. Put a dot. Current is coming out of it. Right? Understand? Stretch the fingers along the current direction. Thumb indicates what? Right hand thumb rule. Like this. Like this. This is the magnetic core, let us say. Non-magnetic core, like this. Understand? Okay. Now, the flux emanated by the secondary winding will try to oppose the primary winding. Yes or no? Then opposite. Then again here. That means like this. You see, the winding is coming out like this. So therefore, it's a leaving terminal. This is entering terminal. Understand all of you? So finally, you got the dots like this. The entire story is only for creating the dots. After that, you must forget the story. Okay? Now you see how you are applying Oldham method. V of t and I of t. L1, L2. I'm just intentionally writing that equation in the complex form or phasor form instead of time domain. Here I have written time domain. Let me write in complex form. So RMS form, V minus j omega L1 into I1, nothing but I. Okay. J omega M, mutually induced EMF, into I2, nothing but I only, right? Because both are in series. But this I1 is entering, this I2 is leaving, minus, therefore opposite sign, plus. Coming to this now, self, minus j omega L2 into I2, nothing but I. J omega M into I1, nothing but I. Okay, so this is minus, this is plus, then is equal to 0. So V is equal to j omega of L1 plus L2 plus L2 minus, right? Look at this, minus 2m into I. So according to Volt method, this is nothing but LAB, right? I. Then LAB is nothing but L1 plus L2 minus 2. This is minus, this is plus. Self minus mutual plus. That means net EMF decrease, net flux got decreased. Both the flux emanated by the primary and the flux emanated by the secondary linking with the primary, both are not in the same direction, opposite direction. Flux opposing case. You call it flux opposing. Two coils are connected in flux opposing case in series. What could be the equivalent inductance? This is what you can say. Understand? This is a series combination. Let's see the parallel combination. The two coils are there here, L1, L2 and M. Two coils are connected in parallel. These are the terminals AB and expected to find LAB. What is LAB? Please note down this. I think you have finished this part, right? So first dots, then volt amp. Remember always LAB or ZAB or XAB in case of magnetic coupled circuits. Go for volt amp method. Okay. Now this is not an ideal transformer because L1, L2 are available. Ideal transformer, no L, no R. Yes or no, all of you? Okay. Well, so now you see. Identify the terminal. Don't worry about these connections. First worry about the relation between the two coils with respect to the non-magnetic core, how they are connected. Okay, the other connections doesn't influence on the dot. Clear all of you? Okay. So let me identify here. This story is only to create the dots, not for any other. So dot, I put it because I identified this terminal is entering. I assume first. Current is coming like this. That's it. Right hand thumb rule, hold, flux is produced like this and interact with this like this, and the flux emanated by the secondary coil will be trying to oppose the flux emanated by the primary. Yes or no, according to Lenz's law. So what is the direction of the flux as far as this coil is concerned? Upward, right? Upward. See, out, it is coming out. So the coils are connected like this. Now here we go with old-time technique. Assume that this is V, this is I. Okay. If we go with say V is equal to, so V and I here. So I is delivered, and say the current flowing here is I, and the current flowing in this one is I1. Understand? Okay. Let's write the equations and get V is equal to something into di by dt. That something is nothing but what? LAB only. Yes or no? Old-time technique. So first equation, loop 1. Plus V minus L1 di1 by dt. Not di1, but what is the current flowing here? This is I. But what is the current flowing? I minus I1. The current flowing to this coil is I minus I1. This is self. What are the mutual? M di1 by dt. Current flowing here, I1. Yes or no, all of you? Okay. Otherwise, if you want, you can use it as I1. This is I2. That will be very easy for you to deal with, okay? Because loop 1, loop 2, something like that. I1 minus I2. And this is what? I2 now. I think all of you clear with this. Okay. Now, L1 di1 by dt. Then M into di2 by dt. But I1 is entering. What is the current here doing? I1 is entering. I2 is also entering. I1 minus I2 is entering. I2 is also entering. Therefore, same sign is equal to 0. Equation 1. Loop 2. Here, minus L2 di2 by dt. Self but mutual. Current flowing through this. What is the current flowing through this coil? Either I1 minus I2 or I2 minus I1. Anything is okay. Suppose if I take, because I'm writing here I2 greater than I1, I2 minus I1. What is the current flowing here? I2 minus I1. Upward. Upward means leaving, whereas I2 is entering. Therefore, plus M D, but I'm taking I2 minus I1 by dt. This is self and mutual of this particular coil. Now again, next one is what this? Minus L1 of d by dt of I2 minus I1. This is what the actual current flowing here in terms of the branch currents. The loop current is I2 and I1, resultant is I2 minus I1. Okay, this is self. What are the mutual again? The current flowing here. So I2 minus I1 is leaving this current. The current flowing here, it is I2 that is entering. Therefore, plus M di2 by dt. That's it. So from 2, simple. Here I1 and I2 are there. Here V, I1, I2 are there. Here there is no V at all. Ultimately, we want the relation what V, I1. V is equal to something into di1 by dt. So from 2, what we do is, you express di2 by dt is equal to something into di1 by dt. You call it equation 3. You substitute this 3 in 1 now. If you substitute, then entire V is equal to something into di1 by dt. Now this is what actually you're looking for. I directly give you that answer. LAB will be L1 L2 minus M square by L1 plus L2 minus 2M. And no doubt it is a flux aiding case. Why? Because you see this current is entering, this current is also entering. Okay. Therefore, flux aiding case it is. It is a flux aiding case. Parallel combination flux aiding case. Okay. Similarly, don't write. Similarly, I'll give you another one also, 7. Similarly, when you have okay, parallel combination. That's it. This is A, this is B. Now the dots, let's see. What are the dots? Here it is entering dot. Flux developed and interacting with this. It opposes. Excuse me. Okay. Now this is the leaving point. This is an entering point. Agree all of you? Okay. So now the coils are coming like this. Now you want to find this. In a similar way, when you write the equations, you will get what here? This is plus, this is minus, this is minus, and so on. And then you simplify it. Finally, the LAB will be L1 L2 minus M square by L1 plus L2 plus 2M. This is flux opposing case. Okay, so two inductors are connected in parallel in flux aiding. That is the formula. Two inductors are connected in flux opposing case. That is the formula. Agree all of you? Please note on that. I'll give another question meanwhile. Please note down that. 8th question. You are expected to find V naught here. This is I2. This is I1. 4 ohm minus J6 ohm plus minus V1 plus minus V2. Dots are here given already. The ratio is given 1:2. It's an ideal transformer, clearly mentioned. The voltage is given here 120 at an angle of 0 volts. Definitely RMS value it is. Okay. You are now expected to determine A, I1, B, V0, C, complex power. Supplied by source. This is the question. That's the question. See, this problem can be tackled in two different ways. When ideal transformer is given, generally we have a standard procedure I explained you in the last session, that you just convert the network from primary to secondary or secondary to primary. So when you refer secondary towards primary, then what are the formulas we have discussed already? Yes or no? V2 dash will become V2 by n, I2 dash will become n times I2, Z2 dash will become Z2 by n square. Similarly, primary to secondary, I1 dash will become I1 by n, V1 dash will become n times V1, yes or no? And Z1 dash will become n square times Z1. That formula we already remembered. But now, the two different ways we can do that is one method we can do, or else we can do another method also. So first we discuss the method what we discussed. Okay, method we apply what we discussed. First we apply the method what we discussed. You convert either to primary or secondary when ideal transformer is given. Okay, doesn't matter whether secondary, primary, doesn't matter. But what is the objective? I1. So let's go for primary. But what is the objective? V0. For this you can go for secondary, or else you can do one thing. You can find I1, then you can find I2 by transformation ratio using, once you know I2, you can multiply I2 and 20, then you can get V0. Once you know I1, and this is complex voltage, complex current, complex power can be determined. S is equal to V into I conjugate. Yes or no, all of you? Therefore, let me use in this case primary, refer to primary. If I apply, then I will get like this. Resistor, capacitor. So this is A, this is B, let us assume. So what is the voltage here? V1. What is this? 120 at an angle of 0 volts. Agree all of you? Then when it comes to secondary side, 20 by n square. What is n Anna here? 2 by 1. So 20 by 2 square. This is 5. Clear? What is this? 4 ohm and minus J6 ohm. This is I1. I1 remains I1. Yes or no? I1 remains I1. But ZL becomes what? ZL by n square. ZL dash, nothing but ZL by n square. That's what I did here. Okay, so refer to primary. Better you write it. When the circuit is referred to primary, I now eliminate the transformer and draw the equivalent of it. So what is I1 on here? I1 is nothing but 120 at an angle of 0 divided by 4 minus J6 plus 5. 120 at an angle of 0 divided by 9 minus J6. If you simplify, you'll get some answer here. Getting all of you? Once you know I1, this I1 is over now. Now what is my next objective? V0. For V0, I need to find I2. Okay. Otherwise, I can also find like this. Once I know I1, this voltage minus this drop will also give me V1. Once I know V1, I can find V2 because V2 by V1 is nothing but 2 by 1. I know V2. V2 is nothing but V0 only here. There are many ways. Yes or no? So let me find first for that B. Okay. Since I know I1, I can find I2 by I1 is N1 by N2, nothing but 1 by 2. So I2 is nothing but I1 by 2. I'll get some value. Then what is V0? I2 into 20. I'll get this value. Yes or no, all of you? Okay. So I'll give you the answers directly here. You can calculate using your calculator, complex mode you are supposed to apply. I'll give you here. This is 11.09 at an angle of 33.69. Understand? But observe this, all of you. We know ideal transformer case. When this is the dot, this is the dot. When I1 and I2 are something like this, you use I2 by I1 is equal to N1 by N2 or minus N1 by N2. Which one you are supposed to apply? Yes. This dot is given here. Okay. I'm sorry. This dot is given here. Please rectify it. The question, in the question, you please observe the question which is available with you in the classroom workbook. The dot was given here. Okay. So please change that. I given wrongly here. In the question given the dot here. Okay. Now when I am finding I2 and I1, the relation between I1, I2 and N1, N2. When I1 is entering, I2 is leaving, this is the relation. But what is happening here? The dot is given in the question. Okay, the dot is given here. So I1 is leaving, but I2 is what? also leaving, then the current will become what? Minus N1 by N2. Yes or no? Therefore, here it is minus. So here it is minus. You have to find that. Getting all of you okay? I think you understand this. When I1 is actually leaving and I2 is also leaving, we have a clear, okay, relationship in case of transformer ratio based on the dots I have given already. This is the benchmark always. This is the benchmark. Yes or no? V2 by V1 is equal to N2 by N1. I2 by I1 is equal to N1 by N2. Anything that changes here, whether the direction, then becomes minus. See this? Now in this case, this is okay, fine. At this dot the current is leaving and here also it is leaving. At this dot the current is supposed to enter, but here it is what? Leaving. So reverse. That is why the negative sign will come into picture. Always compare with respect to this, whether the given transformer, current voltage are given with, same as this or not. This you take as a benchmark example, and based on this you analyze whether the minus sign will come or not. I'm telling you, it's very sensitive. There are many chances to the mistake. If you keep in mind this always, in the relationship of the voltages and currents in terms of the turn ratios, okay, then you can easily solve the problems. That's it. So I'll just give you the value minus 5.545 at an angle of 33.69 degrees amperes, and V0 will be now simply just multiplication. Now this you can express even 5.545 at an angle of 180 plus, because this minus sign you can get push that into angle. Minus 1 is nothing but 1 at an angle of 180, so 33.69 degrees angle. If you multiply that 5.545 into 20, then you will get 110.9 at an angle of 213.69 volts. Okay. But what about the complex power? See, in exam you will be asked only one question. I'm just trying to give you many things here for your practice sake. Okay. So what is C? S is equal to then V into I1 conjugate. What is V? 120 at an angle of 0 into what is I1? Tell me all of you. 11.09 at an angle of 33.69 conjugate. So 120 into 11.09 at an angle of, this is already 0, but what about this? Conjugate means minus 33.69 degrees. I'll give you that answer clearly. 1330.8. Yes, 0.8 minus 33.69 volt amp. What is complex power units? Volt amp. Please note on that, all of you. This is another interesting model. So we're trying to cover different models, okay? All different models, so that in exam we don't know which direction or which dimension you will ask the question. Question number 9. This is another interesting question. I1, this is 30 ohm. This is I2. He has given here 2:1 ratio. Okay, so an ideal transformer. Usually you will mention ideal transformer. Even if it doesn't mention, it is an ideal by default if it doesn't give any reactances. If it's giving only turn ratio but not giving Okay. Any reactances you can treat as an ideal one. Let me remove this part. Please note down that question. The question is, determine the power supplied to 10 ohm resistor. Determine the power supplied to 10 ohm resistor. That's the question. Power supplied to 10 ohm resistor is asking. If you want to know the power supplied to the 10 ohm resistor, you must calculate what? I2. I2 square into 10. Okay. But it is a magnetic coupled circuit. Whenever magnetic coupled circuits are given, first your focus must be, is it an ideal transformer or something else? Ideal or non-ideal? If it is non-ideal, you can directly proceed with the equations. You can do that. If it is an ideal, generally we refer primary side or secondary side. Okay. Even in the last problem also, you can do without, transformation also you can do. I just forgot to explain you. Please go back to the previous problem quickly. Okay. We'll come back to this later. The other method we forgot to, we skipped it, right? So please note down the other method also. I'll just explain. You can solve it on your own. Let me draw the circuit for more understanding purpose. Only method 1 we have done. Method 2, let's see. This is I2, right? V2 plus minus. Here is a dot and here is a dot. This is plus minus V1. This is I1. This is 4 ohm and minus J6 ohm. And this is given as what? Plus minus 120 at an angle of 0 volts. Right. This is 1:2 ratio given. Right. So this is 20 ohm. Right. So now, do we really need to transform it to the primary or secondary towards? Sometimes it's not required even. Look at this, all of you. Without even referring to primary or secondary also, I can solve it. Look at this. If I write the KVL in this, what will I get? Tell me. 120 at an angle of 0 minus 4 minus J6 into I1 minus V1. I'm directly taking the voltage here. Minus V1. That's it. You got the point, all of you? Okay. Directly I can take it. Is equal to 0. This is the first equation. If I write the equation in this, what will I get? Tell me. Plus V2 minus 20 I2 is equal to 0. Yes or no? We know that V2 by V1 is equal to plus minus, but look at this. This dot is given minus sign. It is supposed to be plus, right? But reverse. Therefore, ratio will also become minus N2 by N1. Nothing but minus 2. Third equation. I2 by I1 is equal to usually N1 by N2. Remember the benchmark example. You understand, all of you? Remember that benchmark example. I have shown you that the relations, 4 cases. The first case is very, very important. I2 by I1 is possible in the first case if the current is entering at the positive terminal. But what is happening here? It's leaving. Second case, the current should leave from the dot. Leaving, okay. But one is entering, the other is leaving. Both are leaving here. It is supposed to enter here. Therefore, it is also minus sign. Therefore, minus 1 by 2. Fourth. Solving all this, because the V1, V2, okay, I1, I2, 4 variables and 4 equations, can't you solve them? You can solve easily. So from this you can find I1. Once you know I1, you can directly find I2. Yes or no? Once you know I2, then you can find V2. Once you know I1, you can also find V1, because V1 is nothing but what? 120 at an angle of 0 minus 4 minus J6 into I1. This is also can be applicable. V2 can be determined once you know V1, because V1, V2 ratio is available. So you can also find V0, anything that you want you can find. So refer to primary, refer to secondary need not to apply everywhere, or it's not compulsion. You can also obtain the relations like this, and finally you can get what you want. Now in this case, since there is a connection here between two transformers, here these two are magnetically coupled but electrically isolated. But whereas here, they are magnetically coupled but electrically also coupled. Remember, when they are magnetically and electrically coupled, refer to primary, refer to secondary concept doesn't work. That's very, very important. Transformation primary to secondary, secondary to primary is not possible. That's a very, very important point to be observed. Okay, so in such cases, we can use the second method, method 2, right? What is the method 2? Simply writing the equations and finding the relation between the two transformers, voltage and currents, and then obtain the equations and eliminate whatever unwanted. Try to get the solution. So this I will apply in the same way. I can't really apply primary, refer to secondary concept here. Therefore, look at this now. 120 at an angle of 0, loop 1, minus 20I1. Here I don't know, minus V1 because the polarities are given. Here minus 30 times I1 minus I2 is equal to 0. That's it. Okay. Loop 2. Now you tell me, minus 10 I2 minus 30 times I2 minus I1 plus V2. Look at the polarities, minus to plus. V2 is equal to 0. That's it. Now another relation. These are the two relations. But how many variables are there? 4. V1, V2, I1, I2. I need another two equations. What are they? Look at this. V2 by V1. What is the relation between these two? 1 by 2, right? 1 by 2. But positive or negative, that you have to see. A dot plus is there. Plus is supposed to be there. Plus is there. A dot plus is supposed to be there, but minus is there. Therefore, third relation. In the first winding, the current should enter into the dot. Is entering the dot. No problem. In the second case, the current should leave from the dot. Okay. But the current is entering at the dot. Therefore, I2 by I1 is equal to 2 by 1 but minus 1. That's it. Simple. What is your ultimate objective? I2. So eliminate all other unwanted and find the value of I2. Solving. I just directly give you. Please spend some time to solve these equations. Okay. Should not take much time, I'm telling you. Okay. So finally you find I2. Once you find I2, power of 10 ohm is nothing but I2 square into 10. That's it. So what is that value? I can give you that answer directly. I2 is equal to minus 0.7272. Minus 0.7272. So minus 0.7272 whole square into 10. Okay. That is 5.3 watt. You can take 5.3 watt. That's it. Please note down quickly, all of you.